Assalamualaikum and hi everyone, welcome back to my channel. Siapa yang belum subscribe channel Madam Fika Fiki, boleh tunjukkan support anda dengan menekan butang subscribe. Jadi hari ini kita nak discuss satu set soalan sebagai persediaan bagi menghadapi final exam yang akan tiba tidak lama lagi. Jom kita mula. Alright, so let's discuss question number 1. Question 1A. Find the dimensional expression for, first one is force and second is work. So let's find the dimensional expression for work and force. So we start with force, okay? So we have force, the equation of force, as we know force is equal to mass times acceleration. Okay, we choose sticker. Okay, so make sure, okay, you put a bracket here, this bracket, in order to change or to find the dimension of force, the dimension of mass, and the dimension of the acceleration. Okay, so jangan lupa bracket ni. Okay, so next, and we know that the symbol of dimension for mass is equal to M, capital M, and times, okay, so acceleration, the dimension of the acceleration, as we know, acceleration is equal to V over T. So dimension of the acceleration is equal to dimension of the velocity over dimension of time. And it's equal to LT negative 1 over dimension for time is equal to T. Okay, and therefore the dimension of the acceleration is equal to LT negative 2. Then we put here dimension of the acceleration is LT negative 2. Okay, and finally the dimension of the force is equal to MLT negative 2. Okay, alright, so next, dimension for the work. Alright, so the equation of work is equal to force times distance. So we want to find what is dimension of work and what is dimension of force times dimension of the distance. Okay, remember W is equal to Fs. Okay, so dimension of force is equal to MLT negative 2 times the dimension of the distance is, so distance is length, so dimension is L. Therefore, dimension of work is equal to ML2 T negative 2. Okay, so we move to the second part, which is question B. So, a metal cubic block with an edge of 2 cm has a mass of 5 kg. Find the density of the cube in gram per centimeter cube and kg per meter cube. Okay, so density is equal to M over volume. Okay, so where volume is equal to, so we need to find the volume. Okay, so let's draw. Okay, let's say this is the cube. I know it's a bad drawing. Okay, so 2 cm here, the height is 2 cm. So we have volume is equal to 2 times 10 power of negative 2 because we changed to meter. Okay, therefore the volume in meter is 8 times 10 power of negative 6 meter cube. Alright, so it's given the mass is 5 kg. So we know already the mass is 5 kg, therefore we can find the density is equal to, so the mass given is 5 kg over, so the first one we want to find kg per meter, okay, or we have gram per centimeter cube, so doesn't matter. So now I want to find kg per meter cube first, so 5 over 8 times 10 power of negative 6. Okay, So the answer is equal to 6.25 times exponent 5 kg per meter cube. Okay. And now we want to change kg per meter cube 6.25 times 10 power of 5 kg per meter cube to gram per centimeter cube. Okay. So I want to use cross product. So I want to use cross method. Okay, so look at here. We have 6.25 times 10 power of 5 kg per meter cube. Okay, so now we have here kg and we want to cancel kg. So we put another unit kg at the bottom of the fraction and gram here. So 1 kg is equal to 1000 gram or 10 power of 3 gram. Alright, settle. Then we move to this one. I want to change meter to centimeter. Okay, so look at here, meter. So I put here meter and here is centimeter. Okay, so the unit meter here is at the bottom of the fraction and I put another one, okay, at the top of this fraction so that we can cancel the unit. Okay, so as we know that 1 meter is equal to 100 centimeter, saya tulis dulu 1 meter is equal to 100 centimeter. Okay, but remember here we have cube and we need to put the unit and also the value here, okay, with cube as well. Okay, so this one should be 1 cube, meter cube, 100 cube and centimeter cube. Okay, so now we can cancel. Therefore, we can solve this problem with 6.25 times 10 power of 5 times 10 power of 3 divide 100 cube. Okay, so the answer is 625 gram per centimeter cube, or you can write as 6.25 times 10 power of 2 gram centimeter cube. Okay, pun betul. Okay, so let's proceed to question number 2. Okay, question 2, we have figure 1 shows a stationary object on a smooth table, so means no friction, and the height of the table is h above the floor. The object moves horizontally at a distance of 1.8 meter from position A to B. Okay, so means that from A to B we know that it's 1.8 meter. Okay, so from here to here, so I put SAB. Okay, and what happened after the object reached point B? Okay, and the objects fall onto the floor in 0.6 second. Okay, and from A to B, given that the acceleration of the object is uniform acceleration, not constant velocity, baca betul-betul, uniform acceleration, 1.5 meter per second square. And the time taken from the table, from the top of the table to the floor is t is equal to 0.6 second. Okay, so now we want to calculate what is the final velocity of the object at point B, VB, and what is the value of h. So before we start, let's put UA, since the object is at stationary, so we have 0, and I want to find what is VB here. Okay, so now let's analyze this question. In this question, we have two parts of the motion. The first one is linear motion, the horizontal linear motion, and second one is projectile motion. From A to B, okay, so the yellow color, from A to B, this is the linear motion. Okay, so while from B to the floor, let's say this is the point C. Okay, so here is projectile motion. Okay, so let's write the yellow color. So here is the linear motion Okay. And here is the projectile motion. Okay, now, so let's move to the first part, which is linear motion. Okay, so I think I will use the blue color for the linear motion. Sorry, because yellow color you tak boleh nampak I nak tulis. Okay, so the first one, so this is first, linear motion. Okay, so you know that the block is here from point A to point B. Okay, so this is the linear motion, and here is given as AB is 1.8 meter. So now we can calculate by using the equation of kinematics of linear motion. Okay, so I want to find VB, the final velocity at point B. So VB squared is equal to UA squared plus 2A S from A to B. So since the object start from rest, so UA is equal to 0. So now this is equal to 1. So the acceleration is equal to 1.5. SAB is 1.8. Therefore, VB is equal to, we need to take the square root because this is VB squared. And the final answer is 2.32 meter per second. Okay, so now look at the second part. So we have 2.32 meter per second at point B. The velocity here is 2.32 meter per second. Okay, where at point B, as we know, from B to point C, saya letak point C from B to C, as we can see here, this is the projectile motion, but the object is projected horizontally. Okay, kenapa saya kata horizontally? Asalnya memang VB tu bergerak macam ini, kan? Okay, so it's projected horizontally. So look at the purple color. Okay, so here for the second part we have U. Okay, at point B we have UX is equal to 2.32 meter per second. Okay, so I write here is projected horizontally. Tak ada pun angle. Okay, so when projected horizontally, so we have UX is equal to 2.32, and as we know, UY is equal to 0. Okay, kita tulis balik maklumat yang kita ada. For the second part, we want to solve for the projectile motion. Okay, and the time taken to reach the floor from point B to C is given as 0.6 second. Ini maklumat yang kita ada. Okay, dan kita tahu dia turun ke bawah. Okay. Okay, so kita nak kira apa ni? The value of H. So we want to find H. What is H? Okay, H is the vertical displacement SY. Okay, so H is vertical displacement SY. Alright, so now I want to use equation SY is equal to UYT minus half GT squared. Obviously, we will use this equation because we want to find SY. We do have T and UY is equal to 0. Okay, terus kita boleh selesaikan. SY is equal to negative 1 over 2, 9.81. T is equal to 0.6 squared. Therefore, SY is equal to negative 1.77 meter. Okay, so baca soalan. Soalan bukan tanya displacement, bukan tanya vertical displacement. So no need to put negative sign because negative sign is the direction. Okay, so therefore I will write as, supaya nampak jawapan kita kemas, H is equal to 1.77 meter, ketinggian dia. Okay, ketinggian meja tersebut. Okay, done. So move to question number 3. Okay, question number 3 from chapter 3, momentum and impulse. So now we have a body R of mass M move with velocity U collides and sticks to a stationary body S of mass 4m. Okay, so let's write question number 3. Okay, so this is the floor, for example, and then we have an object here. Okay, tak nak lah yang ni. So this is the object. So I put as R, and this is the second object, and this is S. Okay, nampak S tu lagi besar because the mass is 4 times M. Okay, so the mass of R is M, and the mass of S is 4M. Okay, so the mass of R, so here is R, M, the mass of S is 4M. So this is S and this is R. Okay, so UR is moving in this direction. Okay, so it's not given what is UR. Okay, and US is stationary, so it's equal to 0. And this is before collision. Okay, and this is after collision. Alright, so before collision and after collision, so let's draw. So the condition after collisions state that R and S sticks together. So we have R and we have S. Okay, cool. Okay, so this is R and this is S, and they stick together, and obviously they move with same speed of V. Okay, alright, so now question A, state two physical characteristics of this collision. So let's say we consider it as inelastic collision because they move together, but in order to know the collision is elastic or inelastic, remember we need to calculate the total kinetic energy initial and the total kinetic energy final. Alright, if the total kinetic energy initial is not the same as total kinetic energy final, okay, if KEI is not equal to KEF, therefore this is inelastic collision. Okay, so now to answer question A, alright, two physical characteristics of the collision. So I write two characteristics of the collision, and we consider is it's inelastic. Okay, the first one is the total linear momentum is conserved. Okay, and the total kinetic energy is not conserved. Alright, okay, so B, determine the total kinetic energy after collision in terms of M and U. Alright, in terms of M and U, we want to find the kinetic energy. So let's start. So question B state that we want to find what is the total kinetic energy final, where it's equal to half mv squared, and the final mass is mass R plus mass S times V squared. Okay, V squared here. But now look at here, as we want to find the total kinetic energy final, we do have mr and ms, but we don't have the final velocity. Okay, so we need to find the final velocity first. Okay, so before we calculate the total kinetic energy final, let's find the final velocity first. Okay, by using the conservation of linear momentum. Okay, so conservation of linear momentum state that the total initial momentum is equal to total final momentum. Okay, therefore initially you can see here R is moving but S is not moving. Okay, so formula for momentum is P is equal to mv. Then we can write for R is mr ur plus ms us, and for the final state you can see here they are moving together, so we do have V. Okay, satu saja V lah sebab mereka bergerak sekali, and then we need to combine the mass. Okay, So we have mr plus ms v. So initially, since mass s is at stationary, so this is equal to 0. Therefore, we can substitute mass r is equal to m, ur is equal to u, okay, because we want in terms of u, so we just put u, okay, is equal to mr is m plus ms is 4m v, okay. So from here, we're gonna have v is equal to mu, okay, sekejap, saya kecilkan sikit, okay, where mu is equal to 5m. So v kita dah dapat u over 5, okay, u over 5 meter per second. So the unit is meter per second. Okay, tapi sebab kita tak tahu unit dia dalam apa kan, sebab tak ada kan, dia tak ada bagi unit dalam sentimeter ke meter ke. Okay, so v is equal to u over 5. Okay, so now we can calculate the total kinetic energy. Final is equal to half mr is m plus ms is 4m and v squared is u over 5 squared. It's equal to 1 over 2 5m u squared over 25. So you can cancel this. Okay, so this is equal to mu squared over 10, where 1 over 10 is equal to, so we can write as 0.1 mu squared. Okay, so I just put the unit as joule here, so we can just leave the answer as 0.1 mu squared. Okay, so let's move to question number 4. Okay, question number 4, we have a man pulls a 35 kg block at constant velocity. So I will write constant velocity. So A is equal to 0. Okay, so the man pulls the block with a rope at the angle of 30 degrees to the horizontal. So this is T and this is the angle 30 degrees to the horizontal. Alright, so given that the coefficient of kinetic friction between the block and the surface is 0.4, so mu is equal to 0.4. Okay, and the mass of the block is 35 kg. So before we start, the first question asks us to find the tension in the rope. So we need to draw the free body diagram. So let's draw the free body diagram. So now we have tension and we're going to have wake and normal and frictional force. Okay, so as we have T at angle of 30 degrees to the horizontal, okay, we need to resolve into x and y component. Okay, so we have x tx and this is ty. Okay, where tx is equal to t cos 30 degree. Okay, tx duduk sebelah angle, so cos. Okay, so ty is equal to t sin 30 degree. Okay, and I will write A and its direction is to the right. Okay, kita tarik ke arah sana, logik ni dia bergerak ke kanan lah. So now calculate the tension in the rope. Okay, so question A. Okay, so I will write total Fx is equal to ma and A is equal to 0 because constant velocity, and in x component we have Tx plus negative friction. Okay, Tx plus negative friction is equal to 0 and Tx is t cos 30 equal to mu kn. So this is mu k. Okay, so kita pun tak boleh cari t. Okay, we still cannot find t from total Fx. You can see here we don't have normal. Okay, we do have mu k. We want to find t tapi tak ada normal force. So look at to the free body diagram here. Normal force dekat mana? On y component. So, we can write total Fy is equal to 0. Sebab dia tidak bergerak in y component. So, in y component, we have normal upward direction plus Ty upward direction and plus negative W is equal to 0. Okay. So, from here, we can write normal is equal to W minus Ty. Okay. Where N is equal to mg minus T sine 30 degree. So, I let this as equation number 2 and this is equation number 1. Okay. So, now let's substitute equation number 2 into equation number 1. So, substitute equation 2 into 1. Okay, so T cos 30 equal to mu K N is equal to mg minus T sine 30. Okay, so now let's factorize T because we want to find T. So it can be T cos 30 plus T sine 30 equal to mu K mg. Sekejap, saya tersilap tulis ni. Okay, it's equal to mu K T sine 30 equal to mu K mg. So I want to factorize T. So cos 30 plus mu K sine 30 equal to mu K mg. Therefore, T is equal to mg over cos 30 plus mu K sine 30. So, let's substitute all the values. So, mu K is 0.4. This one is mu K mg. Okay, mu K mg. Okay, so m is 35 degree. 9.81 over cos 30 plus 0.4 sine 30. Okay, so use your calculator to find T, and finally T is equal to 128.83 Newton. Okay, settle question number 4A. So question 4B, calculate the work done on the block if the distance travelled is 6 cm. Okay, so this is the block. So if the block travel s equal to 6 meter. Okay, so what is the work done on the block? Okay, so I think this is a trick question. Okay, so actually if you know the concept, okay, so when the object is moving with constant velocity, okay, the acceleration is equal to 0. When the acceleration is equal to 0, so the total work done on the object is equal to Fa, it's equal to mas. So we can straightly write, since A is equal to 0, so therefore work done on the block also equal to 0 joule. Okay, tak perlu pun kira. Tetapi kalau you nak kira, kita tengok kita akan dapat jawapan kosong tak? So let's try. Tapi habis masa lah kita tulis panjang-panjang kan? Tapi tak apa, kita akan tunjuk. Okay, so we can answer this question just like this. Okay, or we can calculate what is the total work done on the block. Okay, so total work done on the block is equal to work done by the tension on the block. So I put as Tx. Kenapa saya letak Tx? Okay, so look at to the free body diagram here. Okay, because we have T here and we do have Tx and Ty. Okay, so since the direction of S is to the right, and Tx is to the right. So the angle between Tx and S is 0 degree angle. Okay, so they are same direction. Okay, so kalau you nak kira work, so work is equal to Fs cos theta. So kalau you ambil Ty dengan S, macam mana? S is to the right, Ty is upward, so the angle is here is 90 degree. So work tak boleh. Work Ty is equal to 0. Tak boleh. Okay, so I put SWTX, okay, plus work done by the block to overcome the frictional force, WF. Okay, so we can write so WTX is equal to Tx as cos 0. Okay, so plus negative friction F cos plus friction times S cos 180 degree. Kenapa 180 degree? Okay, because friction in this direction and S is in this direction. So S friction, so it's 180 degree. Okay, so now we can substitute the value of Tx. So Tx tadi kita dah dapat dekat atas, where Tx is equal to apa, kita kira lah. Okay, T cos 30 times S, so cos 0 is 1. Okay, friction is berapa friction? Mu Kn, so we need to find mu Kn times S, cos 180 is negative 1. Okay, so substitute the value. T tadi kita dah dapat 128.83 cos 30 times 6 meter, sebab dia bergerak 6 meter, right? Okay, plus negative mu K is 0.4. Okay, 0.4 times mg T sin 30. So normal force kita adalah mg mass 35 times 9.81. Okay, minus, ini awak kena letak bracket ni kat sini. Okay, macam tu. Saya terus substitute, awak tulis satu-satu. 35 times 9.81 mg minus T sin 30. So T sin 30 is 128.83 sin 30. Okay, awak kira. Okay, nanti akan dapat total this value. So this value minus this part, this value, okay, green minus yellow, finally you will have the total work done on the block is equal to 0. Okay, kalau awak tak percaya, awak kira lah, awak tekan calculator. Okay, so ini awak akan dapat, okay, 128.83 cos 30 times 6, you will get 669.42 joule, and here you're gonna have negative 669.42 joule as well. Okay, so bila positif tambah negatif, so akan jadi kosong. Okay, so finish question number 4. So let's proceed to question number 5. Okay, question number 5, we have a Perdana car has a maximum power of 92 kilowatt. Okay, so the maximum power is given 92 kilowatt, so times 10 power of 3 watt. Okay, and may attain maximum speed of 200, so maximum speed of 200 kilometer per hour. Okay, so I will change straightly to meter per second before start any calculation. So 1 kilometer is 1000 meter or 10 power of 3 meter. So cancel kilometer. Okay, 1 hour 3600 second. Kenapa saya suka buat satu-satu ni? Supaya saya tak silap. Ramai student yang silap bila you congak ataupun you main tekan saja kalkulator laju-laju. Okay, so 55.56 meter. Okay, saya suka buat satu-satu. Okay, so now we want to calculate the force of the car at maximum speed. So means that at this maximum speed, what is the force of the car? When the maximum power is 90 kilowatt, therefore P maximum is equal to F maximum V maximum cos theta. Okay, so direction of F and V is the same direction because it's moving in one direction, so it's equal to 1. Okay, therefore we want to find maximum force. F maximum is equal to P maximum over V maximum. Okay, so 92 times 10 power of 3 over 55.56. So it's equal to 1655.87 Newton. Okay, question number 6. We have figure 3 shows a conical pendulum with a bob of mass 60 kg on a 20 meter long string, making an angle of 6 degrees to the vertical. Okay, so it's given the angle here is 6 degrees, where the length of the string is 20 meter and the mass of the bob is 60 kg. Okay, alright, we want to determine the tension in the string. So before we start any calculation, so make sure you draw the free body diagram first. Okay, so we're gonna have downward direction is the weight and outward from the object is tension. Okay, that's all. Okay, so since the object is moving in circular motion, therefore the direction of the centripetal acceleration must be towards the center of the circle. Okay, so saya suka lukis dulu the direction. Saya lukis kecil saja. Okay, this is not the force. The green color, the green arrow is not the force. It's just the direction of the centripetal acceleration. Okay, I use the direction in order to guide me to write my equation. Okay, so saya suka lukis letak macam itu. So this is the center. Okay, so the direction of the centripetal force must be always towards to the center. Okay, so now I want to transfer the free body diagram in X and Y component. Why? Okay, look at here, we have W and here we have T. So we have here T. Okay, it's better. Okay, so now since here is 6 degree, so means that okay, this angle here is also 6 degree. Okay, 6 degree. Okay, so now I want to resolve into X and Y components. Okay, so we're gonna use this color. So this is T. So Ty is equal to T cos 6 degree and Tx is equal to T sin 6 degree. Okay, and the small direction for the acceleration letak dekat atas ni. Okay, so now let's write the total Fx is equal to MAC and the total Fy is equal to 0. Okay, so this is X component. Okay, so AC dia ke kiri, so total Fx is equal to MAC. We have centripetal acceleration, but total Fy is equal to 0. Kenapa? Sebab this is the horizontal plane of motion. Dia bergerak macam ni, horizontal plane. Okay, so now total Fx is equal to MAC, where total Fx kita ada Tx sahaja. Tx is equal to MAC. So we cannot solve for T because we don't have centripetal acceleration. Kita suka bulatkan. T nak cari, ni ada, oh ni tak ada. So, tinggalkan dulu. Alright, so let's move to the second part, which is total Fy is equal to 0. So, in y component, we have Ty plus negative W is equal to 0. So, Ty is equal to W. Therefore, Ty is T cos 6 degree equal to mg, and we can find T, okay, where T is equal to mg over cos 6 degree. Okay, we can substitute all the values. So we have 60, 9.81, and this is cos 6 degree. T is equal to 5, So T is equal to 591.84 Newton. That's all. Okay, so question B, the speed and the period of the bob. Okay, so we want to calculate what is the speed of the motion. So V. Alright, so back to total Fx tadi, we're going to have MAC, where Fx we have Tx, T sin 6 degree. Kita bukan nak cari centipetal acceleration. I change AC equal to V squared over R. Therefore here, mv squared over R. So kita nak cari V. Okay, so V is equal to RT sin 6 degree over M. Don't forget to take the square root. Okay, substitute all the values. So the answer should be equal to 1.47 meter per second. Okay, and next we want to find what is the period of the bob. Okay, period is the time taken to complete one circle. Okay, so T kita nak cari. Okay, so V is equal to R omega, and from omega I can write V also equal to R times 2 pi over T. Okay, you can see here I have T. Okay, so T is equal to 2 pi R over V. Okay, so you can straightly substitute the value. Okay, therefore T is equal to 8.93 second. Okay, we are finished question number 6. So let's move to the last question. Okay, question 7. The moon goes around the earth in an orbit of radius 4.2 times 10 power of 8 meter. Okay, so let's say we have a moon here. The earth. And this is the moon. Okay, this is somewhere there. Okay, and we have so the moon orbiting the earth in a circular path. Okay, sorry for the drawing. I know it's a bad drawing. Okay, so just consider it a circle. Okay, so the moon is orbiting the earth. Okay, so let's write. So this is moon. So this is the earth. And this is moon. So given that the radius of the orbit is 4.2, so it's from the center. Okay, so R, where R is equal to 4.2 exponent 8 meter. Okay, and the mass of the moon is given 6 times 10 power of 24 kg, and the mass of the earth is 7.6. Okay, terbalik. Okay, so this is E and this is M. The mass of the earth here, the mass of the moon here. Okay, so 7.6 exponent 22 kg. Okay, so calculate the gravitational force of the earth on the moon. Okay, so A, we want to find what is the gravitational force. Okay, gravitational force of the earth on the moon. F on the moon due to Earth. Okay, so it's equal to G, the gravitational universal constant, m of the moon and the mass of the Earth over the distance between them, r squared. So you can straightly substitute the value. Okay, mass is 24 exponent 24. Okay, jangan salah tekan kalkulator over r. So r squared, not r. 4.2 times 10 power of 8 squared. Okay, so the answer is 1.72 times 10 power of 20. Unit jangan lupa, the unit is Newton. Okay, you tak letak unit, hilang markah. Okay, and question B, saya letak kat sini lah. Hey, what happened? Okay, question B, the speed of the moon in its orbit. So you can see here, the moon orbiting the Earth, so means that there is the gravitational force between them. Okay, so I will write, okay, the direction of FG is here, gravitational force between the moon and the Earth, FG, and at the same time, we know that the object or the moon is moving in circular motion, so means that there is the Centipetal Force. Okay, FG, okay, the force that provides the Centipetal Force is gravitational force between mass and the Earth. FG is equal to FM. FC, sorry. Centipetal Force. So G, so gravitational force between the moon and the Earth over r squared, and centripetal acceleration mv squared, and this should be the mass of the moon. Sebab moon tu yang bergerak, so the centripetal force, okay, is on the moon. So it's equal to mv squared over r. Okay, so you can cancel out r, the mass of the moon, therefore you can find what is v. Okay, where v is equal to square root gme over r. Okay, so you can see here, okay, the speed of the moon, okay, when orbiting the Earth is depends on the distance between the Earth and the moon. Okay, so if the distance r is increasing, or means that the position of the moon far away from the Earth, so the speed of the moon will be smaller. Okay, because it's inversely proportional. Kalau r increase, v decrease. So v is depends on r. Okay, so now we can substitute all the values. So we can have 6.67 exponent negative 11, 6 times exponent 24, and the distance between them is 4.2 exponent 8. Oops. Okay, so therefore V is 976.14 meter per second. Okay, so that's all from me. So we finished discuss all the questions. So I hope you can understand the discussion just now. Okay, kalau you rasa video ini bermanfaat, you can share to all your friends, and please like this video, share, and subscribe the channel. Okay, so any question you can PM me, or you can put the question in the comment box below. Okay, so thank you. Assalamualaikum and selamat sejahtera.